Okay, thank you, thank you. First, I'm very happy to see all of you here today and to see all of you on the fields of our workshop, international workshop, robotics, math modeling, and AI technologies. I hope our event will become traditional, and as a result, we will increase the number of joint research and publications. And I would like to draw a special attention of my colleagues at the department and at the faculty to take this brilliant opportunity to communicate with our foreign partners. And please be proactive, and your questions are welcome. Today we can see the widest geography of our partners and a quite considerable range of competences and subject area from classical math modeling to advanced technologies of artificial intelligence. And our task is now to find the maximum number of points of contact and growth and outline the ways of development our partnership. And at the moment, I would like to transfer the floor to our moderator, Professor Andrianov. Nikita, the floor is yours. Please do begin.
Thank you, Professor Bitolen, for your presentation, for starting. We have programs, dear colleagues, and we have participants, and the first presentation, the algorithms for control and the simulations of robots by Professor Liang from Shanghai Polytechnic University. Professor Liang, you can have a floor screen.
Yes, Lisa.
And other participants, please turn off your microphones during the presentation. The requirement time is 15-20 minutes. Professor Liang, can you hear me?
Иногда я слышал, иногда я не слышал.
Вы можете расшарить экран, нажав на стрелочку рядом с микрофоном. You can use arrow for desktop sharing. This button near the microphone.
Я слышал, сейчас я слышал. Но иногда я не слышал. И экран стоп.
Может быть, тогда вы выступите следующим, там, попробуйте, у вас есть вот эта вот стрелочка? Или отправить мне презентацию, чтобы я мог ее тогда расшаривать, а вы будете говорить. Можно.
Никита Андреевич, я прошу прощения.
Да.
А может быть, пока коллега решает технические проблемы, сможет выступить другой представитель из Китая? Потому что у них там уже начинается как бы темное время суток.
Сейчас я слышал и очень хорошо.
Это кто тогда?
Доктор Хо Цзяньвэнь.
Я слышал. Я слышал.
Да. Hello, доктор Хо.
Hello. Я здесь.
Dr. Ho, we have some technical problems, so maybe you can present your presentation about soft and bionic robots. Dr. Ho is associate professor at Southwestern University of Science and Technology from China. So please, can you share your screen? Okay.
Сейчас.
Okay.
Секунду. Презентацию вы можете смотреть.
Да, мы можем. У меня видно.
Хорошо. Ну, тогда мы начинаем.
Да, пожалуйста.
Уважаемые коллеги, тема работы управления движением группы роботов на основе визуальной информации от сопровождающего дрона. В настоящее время группа роботов применяется в различных областях, например, в войсково-спасательных задачах, в сельскохозяйственной области, в транспортировке и так далее. Мы заметили, что в существующих проектах группы роботов используются для решения следующих задач. Однако, на практике это может быть не так. Например, приземление дрона или мобильные роботы могут решить задачу сбора информации, но из-за повторных отчетов могут решиться ранее. Поэтому старая информация уже не актуальна. Еще при встрече с препятствиями требуется изменение конфигурации группы роботов, чтобы соотнести ее с формой препятствия. Например, на рисунке группа роботов двигается по первой и второй траектории с различными топологиями. Поэтому целью работы является разработка системы управления движением группы роботов по данным от сопровождающего дрона. Для достижения цели необходимо решить следующие основные задачи. Во-первых, изнедавание организмами планирования траектории движения ведущего робота на основе сопоставления карт, которые построят с использованием данных от дрона и ведущего наземного робота. Во-вторых, разработать методику управления перестроением группы роботов в связи с препятствиями. На слайде представлена структура работы. Сначала проведем обзор существующих алгоритмов планирования траектории с помощью информации от камеры дрона. Мы заметили, что эти алгоритмы имеют некоторые недостатки. Например, динамические препятствия, существующие на карте дрона, не учитываются. Потом рассмотрим некоторые методы для управления перестроением группы роботов. На слайде показаны 5 из типов методов. Далее проведем анализ данных методов. Они имеют свои преимущества и недостатки. Поэтому в работе разработана новая структура управления перестроением группы роботов, которая обеспечивает просторную реализацию, высокую гибкостью и масштабируемостью и низкую сложность вычисления. В работе спроектирована структура системы управления группой роботов. Система включает один дрон и один наземный ведущий робот с группой видимых наземных роботов и управляющий центр. В связи с информацией от камеры дрона управляется движение ведущего робота по траектории и перестроение группы видимых роботов с использованием различных вариантов топологии группы, которые формируют управляющий центр. Нужно отметить, что в работе имеют некоторые ограничения. Теперь мы обсудим первую задачу. Во-первых, по заданию траектории летит дрон и снимает наземные изображения с помощью камер. Во-вторых, ведущий робот получает эти изображения и формирует глобальную карту. Далее ведущий робот строит локальную карту с использованием данных от лазерного старломера. Тогда первая задача состоит в планировании траектории движения ведущего робота с учетом построенных карт и его движения вдоль программной траектории. На слайде показана схема формирования программной траектории движения ведущего робота. Для сопоставления глобальной и локальной карт получено соотношение с помощью преобразования координат из системы координат дрона в систему координат ведущего робота. В этом соотношении имеются 4 неизвестных параметров, поэтому необходимо перейти к
Скажите,
задачу их
пожалуйста, во сколько точно будет
определения.
формироваться карта полета?
На первом рисунке показана процедура нахождения известных параметров. Каждый карта изображения записывается по очереди в буфер ведущего робота. Для формирования глобальной карты необходимо выполнять последовательные действия. Сначала регистрация изображения, потом сливание изображения и еще обнаружение объектов. И потом, наконец, формирование глобальной карты. Дальше ведущим роботом выполняется построение локальной карты с помощью метода SLAM, используя данные от лазера до ромера. Для анализа координация между глобальной и локальной картами были найдены характеристические точки на каждой карте и получена парная точка с помощью следующей соотношения. Тогда таким образом найти 4 неизвестных параметров с использованием метода минимизация квадра ошибка. После построения карты решения задача планирования глобальной с траекторией движения ведущего робота. Обычно процесс планирования траектории с использованием алгоритма совездой необходимо обойти каждый узел. Для уменьшения объема вычисления разработан метод ограничения обхода выделенных узлов на карте. С использованием разработанного модифицированного алгоритма совездой на основе метода ограничения обхода узлов спланирована глобальная траектория. Слева показаны результаты с робота алгоритма до и после ограничения и посещения узлов. Как видно, модифицированных алгоритма выполняет поиск пути в с 1,5 раза. По сравнению с классическим алгоритмом ASTRALT для проверки правильности и работоспособности алгоритма построена схема моделирования планирования траектории в среде РОС. Проверка разработки алгоритма выполнять на модели пример, где в качестве объектов в среде использования обычные предметы изображения сняты камерой дрона и переданы компьютеру через Wi-Fi. Это глобальная карта сформирована в среде масштаба. На рисунке красным цветом выделены характерные точки. На слайде представлены результаты сопоставления карт и планирования траектории. Сейчас я покажу видео результата моделирования. Сейчас. Посмотрите, это с глобальная карта. Это модельный окружающей среды. В окружающей среде есть препятствия, которые осуществуют на глобальной карте. С глобальной карте построена траектория. Когда робот встречается с препятствиями, которые отсутствуют на глобальной карте, в реальное время он планирует движение с помощью разработанного алгоритма. После планирования траектории необходимо решить проблему управления движением ведущего робота. Закон управления разработан на основе модели ошибка. С учетом выражения этого и закон 3. Нетрудно получить закон управления с помощью выражения 5. Результат моделирования показаний 100 через 4 секунды отклонения движения робота от программной траектории приближаются к нулю. Таким образом, решена задача управления движением ведущего робота, но из-за возможно изменение окружающей среды необходимо разработать стратегию управления перестроением группы роботов. Для решения данной задачи были построена структура системы управления перестроением группы роботов.
Осталось у вас 3 минуты.
Окей. Но тогда с дальше доклад я не могу дальше, да. Алло.
Да, 3 минуты у вас еще есть.
Ну, еще вот сейчас покажу.
Да, выводом.
И еще вот это моделирование. Сейчас я могу показать его. Вот это перестроение и вот это движение по данным конструкцию. И вот это лабораторный эксперимент. И вот это с результатом управления перестроением. Но это основной результат. Спасибо за внимание.
Спасибо, доктор Хо. Thank you for your presentation. Colleagues, have you any questions?
Yes, I have a question. May I ask a few questions?
Если есть вопрос, ну тогда скажите.
Да, есть вопрос. Если модератор решит задать, я задам.
Ага, тогда я отвечу.
Да, давайте. Прям, если быстренько, еще пару минут на вопросы, минутки 3. 3 minutes for questions.
Вопрос в следующем. Насколько ваш алгоритм может, значит, соблюдать построение роботов в некоторый строй, и как будет изменяться этот строй, необходимый при объезде препятствий, насколько он будет деформироваться?
Но это время, да. Сейчас не очень понимаю вопрос.
Вопрос в следующем. Вот у вас объезд препятствий группы роботов, которые едут некоторым порядком, некоторым строем, некоторой коробочкой такой вот. Насколько при изменении траектории будет деформироваться их необходимый заданный порядок, как они построены, форма построения? И будут ли они потом восстанавливать обратно это построение после объезда препятствия?
Но обычно на эксперименте только с 5, только 5. На naturally эксперименте только 5.
Ага. Ну, тогда еще второй вопрос, разрешите, тоже задам. Насколько сложной и искривленной может быть траектория при объезде нескольких препятствий?
Не понимаю.
Dr. Hom, may we speak in English, if it's easy for you?
Я думаю, по-русски лучше.
Еще лучше, хорошо.
Вы можете медленно.
Да, хорошо, постараюсь. Скажите, пожалуйста, насколько искривленной, то есть кривой, может быть траектория движения и насколько сложные формы она может принимать при объезде нескольких рядом стоящих препятствий?
Это зависит от размера роботов. Если с робот маленький, но тогда с планированием траектории может быть несколько. Если большой робот, это нужно изменить конфигурацию. Потому что это чтобы обойти препятствия.
Да, спасибо. И еще один вопрос, последний, наверное, уже от меня на сегодня.
Может быть, чат, а мы попробуем перейти к следующему, мы немного удивляемся времени. Colleagues, we are out of time. Maybe you can use chat, write questions for Dr. Ho in chat, and we go to the next speaker.
Yes, of course, we can type in the chat.
Dr. Liang, are you ready?
Спасибо большое, господин Цзяньвэнь, доктор Цзяньвэнь.
Спасибо.
Thank you very much.
Thank you. Спасибо большое.
Спасибо большое вам за выступление.
Dr. Wen, are you ready?
Hello? Hello? Can you hear me?
Oh.
Yeah.
Oh, okay. Okay.
Dr. Zhang, colleagues, if you don't mind, I suggest our another speaker from China, Dr. Xinbin Zhang. He's associate professor at Harbin Polytechnic University, and his topic is programming and building soft robots. Dr. Zhang, you can start. Please, can you share your screen?
Okay. I try to share my screen.
Right to present in maybe
Oh, okay.
15, 18 minutes, please. Okay, I can see presentation.
Okay. Good afternoon, everyone. My name is Zhang Xinbin, and I'm from Harbin Institute of Technology. Thanks for the invitation from Dr. George Musil. It's my pleasure to give a lecture at Financial University. My topic today is variable stiffness in software robotics. Software robot originally comes from the imitation of structure and locomotion in nature, such as elephant nose, human hand, earthworm, and snake, and generally using soft materials like silicon rubber, fabrics, blade materials to construct its main body. Due to the inherent softness and compliance, soft robots have several outstanding advantages over rigid robots, such as adaptive deformation and locomotion to objects and environments, safe interactions with human beings, simple in design and fabrication, and low cost. With the advances in materials and bionics, soft robotics have rapidly become a hot research topic in the past decade. Currently, the research of soft robotics is still at the starting stage, and there are still substantial challenges in front of the widespread application of soft robots, such as function materials, soft sensors, variable stiffness, spectral and dynamical modeling, simulating and controlling methods. Today, we will talk about variable stiffness. Just as the saying goes, each coin has two sides. The inherent softness enables soft robots with unique advantages over rigid ones. Meanwhile, it also brings about the biggest shortcoming of soft robots, low stiffness. Because of low stiffness, they are always accompanied by passive and unpredicted deformations, which greatly reduces the load capacity, motion stability, and precision of soft robots. So imagine that if a soft robot has a high stiffness, it will help greatly to enhance the performance. However, high stiffness and high softness are contradictory. The only way to possess both the two features is to adopt a variable stiffness mechanism. In actual, variable stiffness has always been an important research issue in soft robotics. To bring the advantages of soft robots into full play, an ideal variable stiffness mechanism, the soft deformation and stiffness modulation should be able to operate independently. Only in this way, when interacting with objects, the soft robot can remain in a high compliance state. While holding and operating objects, the robot can switch to a high stiffness state. Till now, several variable stiffness methods have been proposed. Generally, for a mechanical part, the stiffness mainly depends on its material properties and structure features. From this, variable stiffness methods can be roughly divided in two groups, material-based methods and structure-based methods. For structure-based methods, here are two typical ones, jamming and antagonistic stiffening. In daily life, we always see vacuum-packed foods in a supermarket or a store, like rice, tea. Before packing, they are loosely puffed up. While packing, they become very hot. Jamming just works on the same principle. The vacuum vacuumized particles squeeze each other, and the increased friction between the particles increases the stiffness. Here I give two typical examples. The first one is a universal robotic gripper using particle jamming method. The gripper is a bag made of latex rubber membrane, which is filled with ground coffee. When grasping just like fluid, the particles in the bag flow automatically and adapt to the object via gravity force. Then when applying vacuum pressure, the gripper can achieve a very high stiffness and execute stable and high load grasping. However, the universal gripper also has its shortages. When working, because gravity force performs a key role, the gripper could only move downward from a position right above the object, and it's difficult to do that from other directions. So it's short of operation flexibility. Besides, think of that. If an object is more soft and easy deformation than the gripper, then when interacting, it will be not the gripper but the object to deform. So the gripper can't grasp such soft objects. The second one is a manipulator using a layer jamming mechanism. The plastic layer is sealed by latex rubbers. By applying vacuum pressure, the layers are jammed together and the friction between the layers rises so as to modulate the overall stiffness of the manipulator. Because of the use of rigid components, layer jamming methods always lack of softness and compliance. For the antagonistic stiffening method, here I take an example to explain the principle. This is a soft modular joint, which can be used to assemble serious robotic manipulators. Each module contains 3 pairs of chambers and 3 tendons. When bending, the tendons are relaxed, and the bending deformation of the module is controlled by the gas pressure in the chambers. When modulating stiffness, the tendons are tightened to hold and keep the deformation of the module, so as to increase the stiffness. In other words, the variable stiffness is based on the antagonistic behavior between the expanding chambers and the tightened tendons. The performance of a single module is good. However, for a multi-degree freedom manipulator, the design of both structure and control system will meet many challenges. Because soft manipulators have infinite degree of freedom, such many tendons work at the same time will bring about complex non-linearity and strong coupling in kinematics and dynamics. For material-based methods, here are 2 typical ones, shape memory materials and low melting point alloys. For example, this figure shows a kind of variable fabric with variable stiffness fibers. The variable stiffness fiber is made of shape memory materials. By heating, with the temperature rising, the shape memory material translates from glassy state to rubbery state, and the stiffness changes accordingly. The right one is a variable stiffness finger using low melting point alloy. When heating, the face of the alloy changes from solid to liquid, thus the finger switches to a soft state. For such kinds of functional material-based methods, the soft deformation and the stiffness modulation could be completely decoupled. However, for Joule heating method, the heating and cooling processes take a certain amount of time. For the fabrics, the heating time is about 15 seconds, and the cooling time is about 10 to 30 seconds. For the finger, although the heating time is less than 1 second, it takes about 60 seconds to cool. So such material-based methods always leak operation efficiency. Okay, now I have introduced some typical variable stiffness methods for soft robots. Each method has its own advantages and disadvantages. Next, I will share something about an active variable stiffness mechanism we have proposed recently. Soft robotic fingers featuring high compliance and stiff interactions have received substantial attention in recent years. It can be applied to fabricate grippers as end effectors, and it can also be used to assemble robotic hands for artificial limbs. For us, when design, there are two basic concerns. First, how to decouple the variable stiffness from the bending deformation. Second, how to ensure both the high softness required for safe interactions and the high stiffness to execute stable and precise operations. Based on the two concerns, we developed a gas ribbon hybrid driven soft finger. This figure shows the design diagram. The main body is quite similar to other inflatable fingers. What's different is that a ribbon is added on the dorsal side of the finger. The working principle is that when soft deformation is required, the ribbon is in a relaxed state. Then, by inflating, the gas cavities begin to expand, driving the finger to bend inward. Because the gas pressure is relatively low, the finger remains in a high softness state. When stiffness modulation is required, the ribbon is tightened. Then, by raising the gas pressure, the stiffness of the finger can be modulated. In this way, the bending deformation and the stiffness modulation can be non-parallel. This figure shows the fabrication process. The soft finger is made entirely from soft materials. The main body is made of silicon, which is very soft and harmless to human beings. The ribbon is made of polyester silver. The soft finger is prepared by a casting method, and all of the molds are 3D printed. The fabrication process is simple and the cost is very low. The weight of the soft finger is about 30 grams, and the size is about 80 millimeters long, 20 millimeters high, and 30 millimeters wide. The variable stiffness of the finger was analyzed both theoretically and experimentally. This figure shows the pulling force varying with the displacement. The stiffness is the incremental ratio. We can see that with the stiffness increases, the stiffness increases significantly with the gas pressure. When it comes to 35 kPa, the stiffness rises nearly 3 to 6 times. This is the experiment video. It can be seen that by carefully controlling the gas pressure and the ribbon length, the stiffness of the finger can be easily and effectively modulated, while the bending angle remains nearly unchanged. This is the gas pressure, and this is the bending angle. Then we also tested the load capacity of a single finger. This figure shows the results with a semi-initial bending angle of 180 degrees. Without the constraints of the ribbon, when the gas pressure is about 23 kPa, the bending angle reaches about 180 degrees, and the corresponding load capacity turns out to be 414 grams. With the constraints of the ribbon, the load capacity increases nearly linearly with the gas pressure, and when it rises to 35 kPa, the load capacity is as high as 1.25 kilograms, an enhancement of nearly 3 times. To further investigate the application prospect, we assembled a dual finger soft gripper. These photos show the processes of the gripper grasping various objects with different sizes, shapes, and widths. Then people may say that even without the ribbon, the gripper can also grasp such objects. And what are the benefits of variable stiffness? First, without the variable stiffness mechanism from these figures, we can see that the finger usually deforms exaggeratedly due to its inherent softness. Actually, for our soft finger, both bending deformation.
3 minutes remain.
Yeah, okay. Actually, for our soft finger, both the bending deformation and the stiffness modulation are realized by adjusting the gas pressure. That is, when working, some of the gas pressure is responsible for the bending deformation, while the rest part is for stiffness modulation. To better illustrate this point, we carried out experiments of only considering the gas pressure for the bending deformation. Here is the video. From this video, it can be seen that without the modulated stiffness, although the deformation of the finger is big enough for enclosing the target, the gripper failed to pick up the target. From this perspective, in the cases of the ribbon works, it is the variable stiffness mechanism that provides a high enough stiffness for successfully grasping the target. On top of this, another point is that generally for soft finger-based grasping, an active variable stiffness is not necessary for all objects. However, in some cases, controlling the finger stiffness can enhance the quality of grasping, especially for grasping easy deformation objects. Usually, a stable grasp requires a higher gas pressure to afford the weight of the target. However, as the gas pressure increases, the clamping force from the fingers to the target may easily cause undesired deformation or damage to the target. For our gripper, when a high stiffness is required, the clamping force can be offset by the ribbon. To better understand this point, we performed two simple experiments. From the figures, we can see that without the action variable stiffness function, the bag and the sheet deform obviously. When the ribbon-driven mechanism works under the same gas pressure, the objects deformed very little. Therefore, we can see that active variable stiffness can help better preserve the original states of objects during the grasping and operating process. Finally, I give the advantages of our variable stiffness method. First, the variable stiffness mechanism is entirely made from soft materials containing no rigid part, like particles, alloy, or fabric layers. Therefore, our finger has a high inherent softness. Second, the variable stiffness is realized by only adding a soft ribbon, so the finger structure is simple and compact. Third, the bending deformation and the stiffness modulation are completely decoupled. Thus, we can make full use of the advantages of soft fingers. What's more, the finger can work under a gate pressure of below 35 kPa, which is very safe to human beings. Okay, it comes to the end of my presentation. Thank you very much.
Thank you very much for your brilliant presentations. Colleagues, have you got questions?
Thank you very much, Professor Zhang, for your brilliant presentation. And I have a little question for my colleague, Professor Moiseev. And Georgi, could you possibly tell us about your experience in joint research and the way of funding this research? And as I know, you have materials under preparation with our partners from China. And could you possibly say to us some words in this direction? Thank you.
Yes, thank you, Sergey Timurovich. I can tell a few words about this work. We collaborate with Dr. Zhang, and we visit him like a visiting professor in this year, and think that we make our collaboration wider and wider in the next year, and our work will be more science and make a publication in the journal. So we have Ilshad Hassanshin as the head of our robotics laboratory, and I gave him the contact of Dr. Zhang, and I think that he will connect with him in our agricultural and agrotechnical robotics. So I have a few questions for the Dr. Zhang about this stream of the research about applying this technology in the agrotechnical wave. May I ask a question?
Yeah.
So, Dr. Chang, the chicken egg that was in your presentation is a rather hard object. Can this technology make a robot that pick apples or other soft fruits without damage from the trees?
I think it's easy for such kinds of grippers to grab or grasp apple. But what's difficult is how to safely cut the apples off from the trees. Yeah. Oh, okay. I think grasping an apple or other fruits is not difficult. Yeah.
I don't see that in presentation. Do you have any feedback on the mechanical fingers that doesn't wrinkle the surface?
Presently, I have no. I haven't added a sensor to the soft finger because the soft sensor is a very challenging topic faced in front of soft robotics, and soft sensing is another research hot research topic. Maybe we will add some force sensors to on the tip of the finger in the future. Yeah.
Mm-hmm. Yes, thank you very much for your answers. It's very interesting. So we have a project for the robot that pick apples from the agricultural trees, and if you not sorry. And I want you to invite to this project if you have if you want to have a practical application of your technology. We can work remotely from the distance without flying to the Russia in this robot application.
Yeah. Or we can contact email, and I want to know more details about your project. Yeah.
Yes, I will write you more details and the presentation about our project, and we with Ilshad Hassanshin, the head of our laboratory, contacts with you.
Yeah. Okay. All right.
So thank you very much for the good presentation. It's very interesting.
Sorry, colleagues, we are out of time. Dr. Zhang Xingbin, I'm also the participant of project with Apple picking, Apple collections, and I think it's very simultaneous, both semantics. Now we use just manipulators. It's work, but for bad purpose, maybe soft robotics, soft edge will be more effective, I think. And it will be interesting to work together with you, to collaborate. Thank you for your presentation. Colleagues, you can use the chat for questions for Dr. Zhang Xingbin. And we go to the next speaker. It's the first speaker in our program, Dr. Kang Liang.
Yeah.
Are you ready?
Я готов.
Okay. You can start, please.
Я слышал.
18-20 minutes. You can share your screen.
Sorry, it's not clear. Maybe.
Yes, I can see you.
Okay.
You can you see arrow desktop button? It is near the microphone.
Dr. Zhang, the moderator invites a next reporter. Thank you very much. If you don't hear him.
Hello. Sorry for my internet not bad. So can I present Professor Likita? Yeah, I'm in late view, and
yes,
the second. Yeah.
We can go to next speaker, Dr. Liang Liu. Why Dr. Liang ready? Dr. Tran He is Associate Professor of the Department of Electronics Engineering at Taipei National University, and he's also from Vietnam University. And the topic of his presentation is deep learning for object detection. Dr. Li, please start. You can share the screen.
Good.
I see the presentation. 15-20 minutes, please.
Good afternoon, everyone. Yeah, hello, I'm Chu and I come from Vietnam. Today, I would like to introduce to you about the topic it's object detection, and here I want to introduce to you one of my paper is the entitled "Deepness Joy Semantic Learning for Object Detection in Inclement Weather Condition." This is my work just published on IEEE's transaction on pattern analysis and machine learning intelligence in August in this year, and this is I think it's the best journal for this. Yeah, and my name is Lê Trung Hiểu. Yeah. So the contents that I want to introduce to you include three parts. The first is introduction. In this session, I introduce to you about the object detection and the problem of object detection in inclement weather condition. And the second is I want to show you our method how to solve the problem of object detection in inclement weather condition. And finally, I show you some of the experimental results of our method and compare with the competitive methods. Yeah, that as you know, the object detection is the process of finding object instances in stereo image and video, and it plays an important role in our life because it has a lot of application in, for example, in the medical, in the agriculture, in the industry, and so on. And there are a lot of object detection have been proposed in nowadays, especially the object detection based on the deep learning. It's very famous. For example, it is RetinaNet or Jolo or SSD and so on. So as you know, because there are, although there are a lot of object detection methods was proposed, but the problem is that they can only work well on the under normal weather condition. But in how about in the in the inclement weather, such as in the foggy, in rainy or slowly weather conditions? Yeah, normally these methods usually fail to detect objects in the weather. So here the main reasons is that the poor visibility in this weather condition. So here I show you an example of detection results of RetinaNet, one of the state-of-the-art object detector that proposed using the deep learning. As you can see in the normal weather condition, this method can predict very well objects. But in the foggy weather, here is in foggy image, as you can see, it's misdetection of many objects, right? As you can see. So because the main problem is that the poor visibility. So the traditional approach to solve this problem, that means the previous method usually detect object in two stages. In the first stage is for the visibility enhancement or for image restoration. That means we have the degraded image. Success here is the hazy or foggy image is passed through the restoration module, and we will have the clear image or restore image. After that, the restore image will be used as the input of object detection method for detect object to improve the performance. Here I show you some the restoration method. There are also a lot of restoration methods to restore the image or enhance the visibility of image. And for example, here the hazy image, you can see some of the result of some of the restoration method. For example, CIP, ELDNet, or DCPDN. But The limitation of this method is that from this method is relied on the quality of the restore image or the related image from the restoration module. But some of the works also prove that also the restoration model with high performance do not promise the better rendition results, even though it can reduce the performance of object editor compared with directly use the degraded image. And the reason for that is because the restoration model were not changed towards the end of object edition, and the restoration process might have lost the true information. That is discriminative true information of object. So that is reason for the first is limitation, and the second of this approach is that because they lead to the detect object use the two state, so of course they will reduce the detection speed. So how we also solve how we address this problem? The idea here is the idea of our method to solve the problem of object detection in inclement weather condition in package. Here is I take the example in the hazy weather. Yeah. So the instead of detect object in two states.
Мне презентацию вашего доклада для того, чтобы я показал ее нашему директору.
Yes, sorry. Excuse me. Okay, so our method, the idea here is we joint optimize both the restoration and object edition using unified network instead of do two state like the traditional method. The benefit of this our method is that so the restoration can be changed to the end of object edition, so it has potential to improve the performance. And the second benefit of this idea is that we can reduce the chaining time for object edition, and in the inference time. So because we only use the object detection for detect object, so it doesn't. It will remain the high speed of object detector. Yeah. So this is the idea. How do we do that? Yes, we based on the deep learning for this. We propose unified network. This include two sub-network. The first is the detection sub-network. This sub-network is responsible for the detect object. That means for the classification and localization of object. And the second sub-network is the restoration sub-network. This sub-network is used to enhance the visibility of image, or to restore the image. But here we don't use the restore image as the input of object editor. The idea here, we share two sub-networks share some of the first layer, so that the clean feature or the feature generated from the restoration subnet can be used. This clear feature can be used for object edition, so it can help to improve the performance of object edition in inclement weather. Here is especially in the foggy weather. for in detail here, the detection subnet we use the background of this detection subnet we employed the retina net. Maybe you know this for feature ejection, and for the lack of object indicator we employ the feature pyramid network. Why we use this one? Because the benefit of feature pyramid network that they can spread the rich semantic information of object to all the perimeter layer, so that they can handle the object detection in a multi-scale. Yeah. Especially for the small object, this is normally the reduce the performance of object. To change the detection subnet, here we use we need to use two loss functions. The first is classification loss, and the second is localization loss. For the classification loss, we employed the fog loss. Yeah, and you can see the benefit of fog loss here. That means this node we can downweight. Yeah, it can downweight the loss aside for well-classified example, and they can put more focus on the misclassified example during the training, so that it can improve the performance of for classification. Yeah. For the localization, we use the smooth error loss. Yeah, between the predicted loss, predicted blind box and the truth blind box for this. Here you can see the parameter for this. And the second restoration, the second subnetwork is the restoration subnet. Yes, this subnet we designed it include two modules. The first is a common block module, and the second is a feature recovery module. Yeah, the common block module. This is we use we share. This module we use some layer in the detection subnetwork. That means this block share layer with the detection subnetwork for generate the clean feature and clean feature to use in the detection subnet. And the second module is the feature recovery. This module has three submodules. The first is upsampling. Yeah, the upsampling, because for the restoration subnet, the input side and the output side it need to be equal. So here we use the upsample submodule to resize the picture is equal to the size of input image, and after that we use the multi-scale bumping. This one is for feature multi-scale feature ejection for restore image, and the final is the image production. This one we use this submodule for generate the restorations, generate the output image. Yeah. To compute the output image of the restoration subnet, here's the formula that we used for this. Yeah, to change the restoration subnet, we use the loss function. Here we adopt the mean square root between the gradual image and the predicted image from the restoration subnet. So to here after to change, this is the separate subnetwork. So to change the whole model, that means the DNet. We use we change in end-to-end fashion to simultaneously learn about the object classification, object localization, and restoration image or visibility enhancement. Based on this, so that means we can use the clean picture from the clean picture generated, clean picture from the common blocks module can be used for object edition. Here I want to emphasize, I will show that we didn't use the restore image of the restoration sublet for as the input of the object edition like the traditional method. Here we only use the clean picture, the picture generated from each sublet work, and use it for object edition. Is the main idea of this of our method. So in the training, we both the restoration sublet and the detection sublet can will be active, but in the inference time we only the detection sublet will be activated so that the detection time of our method will be remained compared with the base detector. So in the experimental results, I will show you some of the results of our method and the competitive method. To change our network, we use the synthetic foggy dataset. This is we take from the foggy cityscape dataset, and here's the information of the dataset that we use for training and testing. In test state, we use both the synthetic dataset and real-world foggy dataset for test to compare our method with another method. To compare with other method, we conduct into scenario to compare in two cases. In the first scenario, we compare our method with the state object detection method. Here you can see our method is DFNet and compared with another the state object method, such as Retina, Jolo, SFD, and faster RCNN. In the second case, here is some example used for detecting object in the image. And in the second scenario, we compare our method with the combined or combined module. Here is the combination module between the dehaze module between dehaze module and the object detector. In particular, here we use the AOD net combined with the Retina net, CIP net combined with the Retina net, and DCP ADN combined with the net, and to compare with our method. Yeah, this is some we call this the traditional way to do this that I introduced in the before. Yeah, so to compare with our method, so first we use the dehaze method, some dehaze method to generate the clear image. After that, we use this clear image to test on the. We use the clear image or generated image to use as the input of object detector, and here is the Retina net, and we get the result. Yeah, you can see some result of our method and the combination module between the dehaze module and the object detector. Yeah, as you can see, our method still can get the best result compared with another method. And here is some example results in the image that we detect. We use to show in the paper here for our method and some other methods. Yeah, our method still work well on the. It still work well. Work better than another traditional method. And here is some reference that I use in this slide. Okay, thank you for listening. And any question?
Thank you for your brilliant presentation, Professor from here. Colleagues, have you got questions?
Thank you very much, colleagues. We are a bit out of time, so a little question for our moderator. Nikita, could you possibly tell us about our joint work in remote sensing journal? Only a couple of words, please.
Okay, it is not practical application work, it's more review article, and it is a review of different deep learning algorithms in object detection tasks. We consider different architectures of neural networks and their advantages and disadvantages, and compare it. So, but it is about 30-page review. I think it's quite good review. Dear colleagues, I think we can use chat if you have questions, and we many thanks Dr. From here again, and try to next speaker, Dr. Lan. Maybe are you ready now? Can you share your screen? Okay. Dr. Lan. Okay, let's next in our program, Dr. Erbayev, Erbol Tulegovich. Are you ready? You're here. Oh, Dr. Lam.
Моя очередь.
Вообще ваша очередь. Yes, it's your turn.
Я
Can
пришла.
you share your screen, and maybe you can send me presentation, your presentation. I will share it. So, colleagues, I suggest to go to the next speaker, maybe during his presentation. I'll try to get presentation from Dr. Lam. Dr. Lam, it was your screen.
Yes,
Okay.
yeah.
Finally, we can see your presentation. Да, мы видим вашу презентацию. Начинайте, пожалуйста. Постарайтесь 18-20 минут. 18-20 minutes, please.
Сейчас я. Окей, хорошо. Здравствуйте всем. Меня зовут Канлян из Китая. Но, во-первых, позволите мне поговорить грубо о роевых роботах и связанных с ним знаниях. Но это план презентации, введение, примеры, проекты роев роботов, обратное обсвечение роботов, алгоритм Прежде всего нам нужно знать, в чем польза. Пример проекта роев роботов, классификация роев роботов, наземные роботы, над- и подводные, воздушные. Okay. Это наземные. Это британский робот. Британский робот. Это американский робот. Тоже наземный робот. Это тоже наземный робот. Но это британский робот. Здесь это его состав. Это Италия. Тоже наземный робот. Это американский робот. Очень мало. Это его состав. Это над и подводные роботы. Это американские роботы. Но это британский робот. Его состав. Ну, над водные роботы. Это воздушные роботы. Воздушные очень мало. Это космические роботы. Американские роботы. Вес на тонну. Высота 11 метров. Обратное обеспечение роботов. Сначала движители. Второе двигатели устройства. Это движители. Движители это двуногие роботы. Это русский робот. Ну, это американский робот. Alpha-Dog. Это Япония. Это американский робот. Но это мой Бомский университет в Москве. РГС, МГТУ. Но это Япония. Ну, это ползание роботы. Ну, это летание. Это плавание. Это наземные роботы. Ну, это российский робот, русский робот. Ну, это китайский робот. Мои коллеги. Это подводные роботы. Россия. Это воздушные роботы. Израиль. Ну, это бомский робот. Но я работал здесь. Это США, американский робот. Это манипуляторы и захваты роботов. Но это SolidWorks. Ну, это захват компании. Ну, это проблемы проектирования движителей и манипуляторов. Ну, это программный комплекс. Много аспектов моделирования. Ну, это программный комплекс. Это сходится. Это верное решение. Это не верное решение. Ну, это оптимизация конструкции движителей и манипулятор. Но постановка задач. Параметры часовой оптимизации проектируемого объекта. Это тоже только одно критериальная оптимизация. Но это популяционные алгоритмы глобальной оптимизации, вдохновленные природой. Но я теперь я изучаю алгоритмы роя частиц. Но раньше я изучал алгоритм потерянного роя. Ну, а это много. Ну, это постановка задач. Это много критериальной оптимизации. Много. Но это мини. Многокритериальная оптимизация. Но алгоритмы многокритериальной оптимизации. Но это много интерактивный алгоритм. Основной аппроксимации функций преподавателя лица. Но управление роем роботов основной принцип бионический использует популяционный алгоритм. Алгоритм роя частиц, алгоритм роя пчел, алгоритм муравьиный алгоритм и так далее. Но раньше я изучал алгоритм роя пчел. Но теперь я изучаю алгоритм роя частиц. Но классы задач, которые эффективно могут быть решены с помощью роя роботов. Но это исследование некоторой территории с целью обнаружения участка с экстремальным значением заданного вещества. Но это практичный. Второй, в условиях разного рода препятствий достижения точки на местности с заданным координатами. Ну и так далее. Определенные границ области, составление карты заданной территории, патрулирование границ некоторой области с целью обнаружения вторжения. Но это требование к алгоритмам управления роем. Но высокая вероятность локализации участка с неизвестными координатами, возможности планирования траекторий каждого робота и роя в целом, определение границы исследуемой области с заданной точностью, но равномерное покрытие рассматриваемой территории, малую предсказуемость нахождения роботов в каждой из точек границы исследуемой области. Но сначала это гетерогенные рои роботов. Гетерогенные это разные роботы, управляемые с помощью пчелиного алгоритма. Стратегия кормления улья медоносных пчел. Но это непрерывный поиск в окрестности улья цветочных участков, содержащих достаточное для добычи количества нектара. Посещение цветочных участков, изобилующих нектаром, который может быть собран с меньшим усилием, большим числом пчел по сравнению с участками, содержащими меньшее количество нектара. Но это основные функции пчел разного класса. Каждая незанятая пчела может полететь к источнику нектара, следуя за пчелой разведчикам, которая нашла путь к такому источнику. Пчела-разведник, он выполняет вербовку незанятых пчел с помощью танца на специальной площадке улья. Это области танцев. Это завербованная, это рекрутированная пчела. Она следует за завербовавшей ее пчелой разведчиком к области с некоторым и становится таким образом рабочей пчелой вербовку осуществляют те из пчел разведчиков, которые нашли участки, но так далее. Это функция это количество некоторых точки с координатами, которые определяемы вектором x. Но схема поиска пчелиным алгоритм. Первый в случайной точке области поиска D. Обравляем роботов разведчиков. Но второй на основании значения функции fx вычисленных в указанных точках. Выделяем некоторое число элитных участков, соответствующих максимальным значениям целевой функции. Аналогично определяем некоторое число перспективных участков, которые соответствуют значениям целевой функции, близким к максимальным. Но третий. На каждый из элитных и перспективных участков посылаем определенное число рабочих роботов. Используя соответствующие значения целевой функции, находим новые элитные и перспективные участки. При этом выборе учитываем результаты, полученные как роботами-разведчиками, так и рабочими роботами. Но это гетерогенный рой роботов. И это материанский робот. Это ее сын. Сын сколько есть 1, 2, 3, 4, 5, 6, 7, 8. Все 8. Это тоже называют сателлитные роботы. Но ее сыновья. Но материанский робот, это сын, это окрестности материанского робота, X1, X2, окрестность материанского робота, это сын. Но это окрестности и множество соседей робота. Но это мать. Сколько? 1, 2, 3, 4, 5. Его соседи есть 5. Но это множество соседей.
Sorry, Professor Liang, 3 minutes remain. Осталось 3 минуты.
OK， 好，快一点了，我要快一点。好的，那это гомогенный рой роботов. Гомогенный рой роботов. Гомогенный рой роботов это позиция, это как скорость. Но это топология. Но это мой PSO. Теперь я изучаю PSO постановка. Рассматриваем задачу оптимизации. Но это мими. X размерности вектор. Ну, сейчас робот здесь, но выбор есть. Но, наконец, робот выбирает эту сторону. Но это правило обновления позиции частиц. Но это позиция, это velocity, скорость. Но это видео. Но в самом начале роботы или частицы, но это случайно выбирает сторону. Выбирает случайно. Но второй, но сходится. Но сходится. Но это не конце концов, не глобальные цели, глобальные цели. Это глобальная цель, это локальная цель. Это не хорошо, это лучше. И здесь частицы отсюда и уходит туда. Но введение это в конце концов все частицы вблизи к конца, конец. Ну, это мой модифицированный алгоритм оптимизации роем родис частиц, ориентированный на задачу группы роботов. Но тоже рассматриваем задачу оптимизации. Но сейчас я выбрал целевую функцию 3, сфера, растренген, Розенброк. Но это постановка задачи функция сфера, функция растренген, функция Розенброк. Но это результат цели, это цели. Но модифицированный алгоритм, но ограничение скорости. Это изменение скорости, это множество соседей. Но скорость робота не может быть чрезвычайно большой. Но когда частицы находятся близко к цели, частицы медленнее. Но радиус связи частиц ограничен. Но это проактивный. Но это для оценки значения показателей эффективности алгоритма использовался метод мультистарта с числом стартов m равно что? Оценка. Оценка это первая, это лучшее помнить старту достигнутую значение целевой функции. Но это вторая, это лучшая координата позиции. Это вероятность позиционирования минимального значения. Ну, так далее. Все 7. Это 7, это среднее по мультистарту числу испытаний. Ну, это результаты эксперименты оценка. Но здесь чем меньше значение, и тем лучше. Эффективность алгоритма PSO плюс близко к эффективности канонического алгоритма PSO. Но близко. Но это. Но по показателю F4 алгоритм PSO плюс оказывается заметно лучше, чем PSO, канонический PSO. Но это точность позиционирования. Это здесь чем больше значение, тем лучше. Чем больше, тем лучше. И видно. И PSO плюс лучше. PSO плюс лучше. Но мой модификационный алгоритм лучше. Ну, этот рисунок здесь алгоритм PSO плюс не очень хороший и медленный, но 26%, но хуже алгоритма PSO примерно на 26%. Для функций сфера, Раскина, Зосенброк, соответствие. Но это итерационная оценка эффективности алгоритма. Но это из рисунка следует, что с точки зрения этого показателя алгоритму PSO плюс примерно эквивалентен алгоритму PSO, каноническом PSO. Производительность двух алгоритмов одинакова. Но однако просто мой улучшенный алгоритм может быть практичным. Но результаты исследования показатели эффективности предложенных алгоритмических программных решений и перспективности использования алгоритмов PSO плюс для решения указанного класса задачи грубого и робототехники. Но это ссылка по теме. Это моя контактная информация. Если у вас, если хорошо. Но я закончил.
Спасибо, доктор Лан. Thank you for presentation. We are out of time, colleagues. I suggest to use chat if you have any questions. And sorry for another replacements in our program. We have speaker who is hurry up for meeting. Is Professor SQL.
Nikita, sorry, I have a little, not a question, but a little comment.
Okay.
Thank you very much. Thank you, Professor Lian. And yeah, thank you very much. And we have a joint research, and we have publication concerned to mathematical model for 6 degree of freedom manipulation robots. And we have the paper parallel computational algorithm for object-oriented modeling of manipulation robot. So, and now we are looking for the ways of funding our project. Thank you.
Спасибо, хорошо.
Thank you, Professor Lian. Okay.
Спасибо.
Thank you, Professor Lian. And next speaker is Manuel Liotta SQL. He is a professor at the University of Lisbon from Portugal. And the topic of his presentation is models of the relationship between the price and liquidity of assets with switching of different modes. Dr. SQL, please start. Please 18-20 minutes. We can't hear you. Your microphone is turned off.
So, thank you very much for the invitation. It seems to me that there is some changes in the program, because what I was supposed to do today should be short presentation of research results of our team. And the topic that you mentioned, I will talk about it tomorrow, I think. This is what I was told. Okay? Can it be like this? Okay.
You can share screen.
Okay. Let us start. I will try to show you what's happening in the research in actuarial and financial mathematics at the research center, CMA, of the new University of Lisbon in Portugal. So I will just pick some highlights. What is the CMA? The CMA is a research center in mathematics, and it is the only one of the new University of Lisbon, and it is placed in the Faculty of Science and Technology of the new University of Lisbon. So let me show you a little bit about this center. So we have 103 members, but not all of them are integrated members. This means that not all of them satisfy the productivity criteria that integrated members are obliged to. So also some of them are collaborators from other universities. And then we have the PhD students, which are a special group of researchers. So the research in the center is grouped in 4 lines of research. So there is algebra and logic. Then there is operation research. There is analysis. And then there is statistics and risk management. So we are the statistics and risk management is the largest group. And here you have on the right, you have the distribution among genders. So it's fairly equilibrated. About the PhD students, this is important because the PhD students are the future. Inside the CMA, there are they are considered as researchers in the CMA. There are 14 PhD students from 14 nationalities. There are 4 postdoc researchers and then 4 full-time researchers from 8 institutions in total. But besides these 14 students, there are more PhD students that are supervised, but in other faculties. And in any case, there are 23 master students being supervised nowadays, presently. So our team in actuarial mathematics. So this is a kind of selection because there are more people, but I just chose these 4 to have the opportunity of giving you a presentation of some highlights of what we are doing. So this presentation in PDF has the links to a more complete description of the work of these researchers. So if you are interested in knowing exactly what each one of them is doing, with this link you can go and see all the works that they have been doing. So, but let me first tell you something about a complementary aspect of this, of the research, which is where do students come from? So at the faculty, we have an undergraduate program in mathematics applied to risk management. So this is 3-year course that give you a diploma. So this is a very nice diploma in mathematics, and a program in mathematics, in initial university mathematics, that has a lot of demand. A lot of people want to do this program. And the program wants to prepare students to the actuarial mathematical master. So this is a 2-year program that complements the previous one. And this is a professional grading course program with 2-year courses that prepares, and a thesis that prepares students to become an actuary. So to work in insurance companies and also sometimes in investment companies also. So if you want to have more information about this, the link below also drives you there. And then in financial mathematics, we have a branch of the master degree in mathematics and application. This is also an interesting way of getting a diploma on financial mathematics, but it's not as the previous one, as the one in actuarial mathematics, because the one in actuarial mathematics, it gives you a way entering a profession, the profession of actuary. As this one just gives you know-how and techniques to work, but it doesn't give you the entrance in a profession. So now let us see the team in financial mathematics. So you have, again, I chose some that are relevant to what we wanted to show. We have people working in pricing of derivatives, and then something that is particular here, which is a kind of regime switching stochastic differential models, and then also some work has been done in portfolio management. So let me detail a little bit about the work. So Pedro Mota, he works mainly on regime switching and statistical estimation of diffusions, but he also does other statistical work. So I chose 3 papers from him, and of course you can if you can look at the edition of the paper by clicking in here in this link. So this is the second one is a more statistical paper, and a lot of enterprises in the Standard & Poor's and other indexes are analyzed in what concerns the normality of the returns. And this last work is something very interesting, which is a way of estimating coefficients of diffusions that is based on the assumption that sometimes the diffusion, although not being ergodic, mimics the behavior of ergodic diffusions. So Marta Faiz is another thing, it's completely different. She works on mathematical economics in equilibrium theory, and also she does work on game theory. I chose also 3 papers. The one is clearly a theoretical work in mathematical economics. The second one is much more applied work based on game theory for management, and the third one is again mathematical economics work with a lot of equilibrium theory on it. So Fernanda is a specialist in stochastic analysis. So she works mainly as, for instance, the second and third paper show, she works mainly on stochastic analysis of the functional type. So this is a quite theoretical work, and she is working intensively on fluid dynamics differential equations. And but also she works, she has been working also recently in financial mathematics, and this is the paper that they published this year in the SIAM Journal of Financial Mathematics on determination of the optimal portfolio. So what they do is they use stochastic optimal control with a stochastic volatility model. So Gracinda is specialist in open Markov chain models. So this is something also that was studied initially by different authors, people in Greece, people in the United Kingdom, we started to look at this by another way, by another direction. And we managed to create a body of results that complement the previous approaches. So this line of work of open Markov chain models is very well demonstrated in here, in this, the second and the third papers that I chose. Just for explanation, an open Markov chain model is just a model of some phenomena by a Markov chain, but the population admits the entrance of new members and the exclusion of others. So instead of looking at the asymptotic behavior, for instance, of determined population, you consider that the population varies. People enter, or elements enter in the population, and other elements get out. And the thing is that despite the fact that you have this non-permanent population, what you have also, in certain cases, of course, is that you can determine the distribution of the population in each class according to the distribution of the incoming population. So we can apply this to consumption credit and also to other situations, to bonus malus in insurance, and this is what is done by the team encompassing Guerreiro, the previous researcher, and Maria de Lourdes Afonso. Maria de Lourdes Afonso works mainly in actuarial mathematics, but also we can work together with the actuarial mathematics and the open Markov chain models. For instance, in bonus malus, this is what is dealt in this first paper, and also in the second one. The third paper is a little bit different. It's on operational risk, and it shows the way of not getting bothered by a bias in the way of collecting information for operational risk. So it's also much more applied. And then you have another another researcher that works in actuarial mathematics and mainly in ruin theory, risk theory and ruin theory. And you have three papers that all look at what happens to the ruin probability, but in different setups. Myself, I work with several colleagues. So the second and the third paper are one in the open Markov chains, but the idea is to look how to, in this paper, in the second paper, to look how we can get from the discrete time observations to continuous models. The third paper is one of our first papers in regime switching diffusions, where we look at we applied it to a lot of companies, and we studied comparing the Black-Scholes model and the regime switching model. And this was published in Quantitative Finance. But since then, we have a lot of work, but this is more or less the first one. And I chose also as first paper something that is not really, it is a line of research that wanted to make the connection of the statistical part. And this is a work that I've done with researchers from Rostov University, in Russia, Nadezhda Kradze, and the main goal of this was to build a kind of neural network, but in which you can have a look at what the information structure of this neural network is. And so instead of looking at as a neural network, a classical neural network where you don't have any information on what's going on inside, with this kind of construction, you have everything, the representation of the knowledge is given by a very large dimensional Gaussian distributed random variable. So this is all. Let me just show you what happens. Let me just try to show you what happens if you click in one of these things. Okay, so it goes. I hope that it goes to. I hope that you can see the paper here. So this is more or less. I hope that you can see it. But in any case, if you want further information, you just ask the organizers for the PDF that I sent to them, and you will have access to all this information. So I stop here. Thank you very much for your attention.
Thank you very much, Professor Esquivel. And I have a little question.
Yes.
You said that you had an experience of common publication with our colleagues from Rostov. And my question is, do you have an experience of joint application for funding in our country or in the European Union?
Not yet. Not yet. We are. This was the second part of our my intended presentation, because I thought that we were going to talk a lot more, and we are just making a shift in the direction of our work, and of globally at the center in the statistics and risk management group. And this is turning the research towards the data science and also decision processes. And why is this? Because there is a very important change in what's happening everywhere in all the science at our faculty. And this is the automatization of the collection of information. So we have a lot of devices that collect information constantly. So this gives a huge amount of information that must be treated. And it is with the statistical tools and the high-dimensional data methods that we can look at this. And we are preparing to submit a research project in which there will be, I hope, Russian researchers together. But this is a project that we are going to submit to the funding of Portugal, Portugal Research Foundation. But maybe if it works, maybe we can go to European Union. So to get, but there is a lot of possibilities. The only thing, there is a lot of possibilities on that. The only thing that is, it requires a lot of bureaucratic work. You have to work a lot. To write a lot of things and to prepare a lot of documents, and this can be a little bit discouraging, because you will spend more time preparing documents than doing research.
Thank you very much for your answer. And as
You're
for me, we have enough common points, and we have enough colleagues in our at our department and at our faculty in the same area, scientific area, in the financial mathematics, risk assessment, and so on. And I think that with my colleague Victoria, we will formulate the offer, and I think we are going in the direction of the funding our research, joint research. Thank you very much.
You're welcome. We intend to start cooperating in the writing of a paper that I will present tomorrow.
Thank you very much.
With Victoria,
Thank you.
Yes.
Thank you very much for presentations. Whether your colleagues have got any questions more? And maybe I have one question. You use Markov models and some types of wavelet transformation, and maybe do you use some deep learning models?
No, this is completely different. In this work, what we do is we take the incoming signal and we decompose this signal using wavelets, and we keep track of what happens in each of the coefficients. And then we have a process like this with deeper and deeper decompositions, and we always keep track of what happens in the coefficients. If you have another stimulus, you have a new input. What you have is that in each coefficient you have new observations. When you do this a lot of times, you have a distribution, a probability distribution, which is Gaussian in each coefficient. And then you can also compute the covariance. And globally, the whole coefficients have a Gaussian distribution. So then there is a feedback process that is inside this, and this modifies the distribution in the coefficients. And what we showed in this paper is that with this method, there is stability, in sense that the sequence of Gaussian distributions converge to something. And this is also a Gaussian distribution with I dimension. And this is where all the information is, in this big Gaussian distribution. So, and we applied this in a very simple way, but of course more research is needed. And so this is only the initial research, I think.
Thank you for the answer. Colleagues, I suggest to use chat if you have any more questions. And we go to the next speaker. In accordance with our program, it will be Dr. Ebaev, Erbol Plegovich. Can you see me? Erbol Plegovich, вы готовы?
Да. Здравствуйте, уважаемые коллеги.
Вам слово. Старайтесь 18-20 минут, пожалуйста.
Хорошо, буду краток. Здравствуйте, уважаемые коллеги. Меня зовут Ербол Тулигенович, фамилия Ербаев, из города Уральск, Западно-Казахстанской области, Республики Казахстан. Очень приятно побеседовать, послушать хорошие презентации. Так, хотел бы сделать доклад на тему силовая электроника, основы современных электрогенерирующих ветроэлектрических комплексов. Так, сейчас демонстрацию. Демонстрация экрана видно же, да?
Пока не видно.
Не видно?
Там есть стрелочка вот рядом с микрофоном. Открыть панель обмена контентом.
Во весь экран поделиться.
Да. А вы можете попробовать выбрать рабочий стол или окно?
Открыл.
It's okay. Все хорошо, видно теперь.
Видно, да?
Да.
Ага. Вот, тема доклада «Силовая электроника. Основа современных электрогенерирующих ветроэлектрических комплексов». На современном этапе развития ветроэнергетики имеется два самостоятельных направления. Первое – это разработка, создание и внедрение ветроустановок большой мощности. Второе – создание и внедрение ветроустановок малой мощности локального применения. Когда я учился аспирантом в Саратовском государственном техническом университете имени Гагарина, мы как раз проектировали именно мультимодульную ветроустановку. Руководитель был Степанов Сергей Федорович, профессор, доктор технических наук, и Артюхов Иван Иванович на кафедре электроснабжения промышленных предприятий. Следует отметить, что и в первом, и втором случаях электрические станции, кранцы ВЭС, и установки выполняются с применением элементов силовой электроники, обеспечивающие эффективную работу ветроэнергетическую установку в условиях нестабильности ветрового потока, а также и режимов нагрузки. Нестабильность ветрового потока является существенным препятствием на пути повсеместного использования ветроэнергетических установок. Непостоянство скорости ветра и переменный характер нагрузки приводит к изменению частоты вращения ветроколеса, ротора генератора и, как следствие, к изменению напряжения электрического генератора в широких пределах. В этой связи актуальной является задача разработки целого комплекса мероприятий по поддержанию заданного уровня частоты напряжения и мощности ветроустановок при работе в условиях нестабильности ветрового потока. Эффективное решение данной проблемы возможно только за счет применения как раз силовой электроники. Ранее говорил, вот это мультимодульный шестилопастное вот это ветроколесо, которое мы исследовали именно одно ветроколесо при помощи электроавтомобиля, то есть автомобиля. При несколько километров в часов мы определяли вот скорость ветра, то есть создавали искусственную скорость ветра, поток, и определяли вот частоту, то есть мощность самого ветроколеса. Далее на слайде показано у нас представлено семейство типовых нагрузочных характеристик ветрогенератора мультимодульной станции в зависимости от угловой скорости вращения ротора и скорости ветра, то есть угловой скорости и значение как раз каждой скорости ветра мы определяем вот значение максимальной мощности. Как видно из рисунка, выходная мощность ветрогенератора растет с увеличением скорости ветра, а максимальное значение этой мощности смещается вдоль оси числа оборотов. Для каждой скорости ветра существует строго определенная точка на механические характеристики, где выходная мощность максимальная. Эта точка называется точка максимальной мощности. Для того, чтобы иметь возможность получать максимально возможную мощность от ветроэнергетических установок при любых скоростях ветра, необходимо регулировать скорость вращения турбины так, чтобы она всегда соответствовала оптимальной скорости вращения при данной скорости ветра. В зависимости от мощности и особенностей конструкции ВЭУ требуется свой контроллер управления, учитывающий особенности работы ВЭУ в конкретных условиях. При этом не существует контроллера, которые бы не были бы универсальными и подходили бы для любой ветроустановки. Далее представлен у нас рисунок принцип поиска максимума мощности, где не учитывается коэффициент использования энергии ветра и быстроход ветроколеса. Принцип поиска точки максимальной мощности основан на расчете и анализе производной, то есть отношение мощности к угловой скорости, равной нулю. При значении этого значения мощности находится в точке максимума. При значении производной меньше нуля точка на мощностной характеристике смещена вправо от точки максимума. Для возврата этой точки нам необходимо уменьшить частоту вращения ротора генератора. А если при значении больше нуля, то на мощностной характеристике смещена влево. Значит, нам нужно увеличить частоту вращения ротора генератора. Величину скорости вращения ветроколеса можно изменять за счет изменения выходного тока генератора, создающего электромагнитно-тормозной момент. Для изменения тока генератора в схему ВЭС введен импульсный регулятор тока заряда аккумуляторных батарей, который представлен на слайде. При этом синхронный генератор на постоянных магнитах должен быть рассчитан так, чтобы при минимальной рабочей скорости ветра амплитудное значение напряжения было несколько выше напряжения аккумуляторной батареи. Импульсный регулятор тока заряда содержит регулирующий транзистор, здесь указан VT1, переключающийся с определенной частотой и состоянием насыщения в состояние отсечки. Также у нас указан компенсирующее устройство, входные дроссели компенсатора, датчики напряжения, датчики тока, сам выпрямитель, регулирующие транзисторы, дроссели импульсного регулятора зарядного тока. Величина выпрямленного напряжения определяется скважностью, которая определяется разностью между сигналом напряжения обратной связи и опорного пилообразного напряжения и частотой управляющих импульсов. Управляющие импульсы переменной частоты формируются в блоке управления схемы ШИМ, широтоимпульсной модуляции. Микропроцессорный блок управления, входящий в состав модуля, выполняет следующие функции. Во-первых, формирование величины тока электромагнита, электромеханической системы перемещения ветроколеса. Во-вторых, обеспечивать зарядный ток аккумуляторной батареи непрерывным током. Заряд аккумуляторной батареи при постоянном напряжении, то есть компенсация тока саморазряда аккумулятора. И в-третьих, слежение за точкой максимальной мощности ветрогенератора при изменяющей скорости ветра и нагрузки. Отличительным признаком систем экстремального управления является наличие у объекта управления статической характеристики с явно выраженным экстремумом, достигаемым при определенных значениях входных сигналов. Эта характеристика во времени не остается неизменной. Ветроэнергетическая станция как объект управления является нелинейным объектом. Зависимость мощности ветрогенератора от частоты вращения ветроколеса имеет явно выраженный максимум. Далее показана у нас на слайде имитационная математическая модель, так называется компьютерная модель, где модель сделана в программе MATLAB с пакетом моделирование Simulink. Электрогенератор на постоянных магнитах, система регулировки выходного напряжения, аккумуляторные батареи, электрические преобразователи системы управления и контрольно-измерительные приборы. Моделирование системы выполнено с использованием пакета, как я говорил, который позволяет исследовать динамические, переходные, аварийные режимы при работе на электронагревательной нагрузке и на заряд аккумуляторной батареи. Используя принцип ШИМ, то есть изменяя скважинность импульсов, осуществляется регулировка тока заряда аккумулятора и тем самым изменение мощности, забираемой от генератора и ветроколеса. При изменении тока генератора изменяется величина электромагнитного момента генератора, являющегося тормозным для ветроколеса. Таким образом, при изменении величины тока генератора происходит изменение частоты вращения ветроколеса до оптимального значения, соответствующей точка максимальной мощности. Выходные параметры импульсного регулятора зарядного тока определяются по формулам, где выходные напряжения ток регулятора, напряжение 2, выходное напряжение регулятора, и альфа у нас коэффициент заполнения импульсов. На основании принципа сохранения энергии можно написать следующие формулы, которые показаны на слайде. Контроль точка максимальной мощности при переменной скорости вращения ротора ветрорегенератора позволяет максимально преобразовывать энергию ветра в электроэнергию. Целевая функция при этом может быть записана как максимальная мощность генератора при наличии импульсного регулятора зарядного тока, система поиска точка максимальной мощности. Также записана формула коэффициент заполнения импульсов, которая определяется вот по этой формуле. Далее на слайде максимальное отклонение мощности от точки максимальной мощности без системы регулирования составляет по расчетам вот 72%. Максимальное отклонение мощности мультимодульный ВЭС с экстремальным регулятором от точки максимальной мощности не превышает 4,5%. На слайде показаны мощностные характеристики ветрогенератора мультимодульный ВЭС с синхронным генератором на постоянных магнитах. При наличии экстремального регулятора и работе модуля на электронагревательную нагрузку различной величины, то есть исследования были от 0,5 до 2 Ом. Мощностные характеристики, вот генератор показано, здесь показана точка максимальной мощности при 0,5 Ом, 1 Ом и 2 Ома. Ну, в общем, вкратце у меня все. Доклад окончен. Спасибо за внимание.
Thank you very much. But first, I would like to apologize to our English-speaking partners and colleagues. But we will try to share all information in brief in our social media. So, and I have a little question to our colleague from Kazakhstan. Ербол Тулегович, ну насколько, не знаю, насколько вам известно, мы планировали и планируем достаточно широкое взаимодействие с вашим вузом. Мы, значит, ваш ректор в составе делегации собирался приехать к нам на форум, но, к сожалению, вот он перенесен на апрель. Думаю, все в силе, и мы как бы подтверждаем намерение о сотрудничестве. Да? У нас широкое, так сказать, поле в прямом и в переносном смысле до сотрудничества, сельское хозяйство. Вот вы сейчас подняли пласт проблем возобновляемой энергетики. Могу сходу вам, к сожалению, вот мы сегодня немножко подзапаздываем, и, конечно, хотелось бы больше времени на обсуждение, и мы обязательно как бы проведем еще встречи, точечные, адресные. Значит, мне хочется обратить ваше внимание, есть такая программа развития карбоновых полигонов. Значит, министр образования встречался, Российской Федерации, где-то в феврале-марте встречался с вашим министром, и было обсуждение развития карбонового полигона на территориях Казахстана. Значит, вот теоретически мы могли бы попробовать с вами попасть вот в этот вот глобальный проект, да? Но это вот только одно из направлений. Плюс, насколько мне известно, вы... Да, прошу прощения. Вот, плюс, насколько мне известно, вы уже начали сотрудничество с нашими коллегами в публикационной активности. Мы будем тоже это всячески поддерживать. Вот. Ну и, собственно, надеюсь, что наше сотрудничество только начинается и с вами лично, и с университетом. Будем рады, так сказать, дальнейшему развитию. Спасибо.
Спасибо за приглашение. Я очень рад.
Коллеги, если есть какие-то вопросы, ну, действительно, можно в чате что-то писать. Давайте в рабочем порядке будем, так сказать, взаимодействовать и движемся дальше по программе, если вы не возражаете. Мне ничего не слышно.
Sorry.
Все отлично. Ага.
Microphone was turned off. Our next speaker will be Maria Antonietta Pascali. She's a researcher at the Institute of Informatics and Technology from Italy, and her topic is ecological data analysis, theory, applications, and emerging trends. Dr. Pascali, please.
Thank you very much. Thank you very much for the introduction. Could you hear me? Could you see my screen?
Presentation is okay, and we can see you.
Okay, the presentation.
Please, 15 minutes, if you could.
Okay, sorry, excuse me. Okay. Thank you for the invitation, for giving me the opportunity to take part in this workshop. I'm a researcher of the Signal and Images Laboratory of the National Research Council of Italy. And I'd like to provide a short introduction to the use of computational topology methods in data analysis, describing also some applications and new trends. In particular, I refer to the recent efforts of researchers around the world, aiming at integrating topological methods to enhance or augment both classical machine learning methods and deep learning models. The fundamental ingredient of this report is algebraic topology and topology. Topology is a branch of mathematics able to inform us about global properties of data space, even in presence of noise. It's a very powerful tool for analyzing shapes. It studies properties of spaces that do not change if we stretch or twist the shapes without cutting or pasting the shape in any way. Algebraic topology creates the algebraic representations of data space properties, for example, holes, which are powerful and computable invariants for studying, analyzing, and comparing data. The most famous invariants are the Euler characteristic and Betti numbers. These are strictly related to a very important class of invariants, the homology groups, which encode a great deal of information while still being efficiently computable in many cases. The homology groups To formally define the homology groups, we should introduce the simplicial homology as an algebraic object to be assigned to an n-dimensional abstract simplicial complexes. A simplicial complex is built from points, edges, triangular faces, and homology counts components, holes, voids, and so on. Okay. Homology of a simplicial complex is computable via linear algebra. Sorry. Okay. The homology group arises from combinatorial representation of the manifold, the chain complexes. In the picture, you see, for example, a curve on the mesh on the left is a one-dimensional chain, while a surface patch on the same surface is a two-dimensional chain. The other ingredient needed to define the homology group is the boundary operator. The boundary operator is the formal sum of the pi-1 dimensional faces of a P chain sigma J. A boundary has no boundary, and this operator connects the vector spaces into a chain complex. P chains that have no boundary are called P cycles or closed P chains, and they form a subspace ZP of CP. The P chains that are the boundary of P plus 1 chains are called P boundaries or exact P chains, and they form a subspace BP of CP. Hence, we are able to give the definition of the homology group. The homology group is the quotient group, the quotient between the two subspaces defined in the slide before. The rank of this group is the p-dimensional Betti number of the simplicial complex, and is denoted through beta p. It is a measurement of the number of different holes, p-dimensional holes, of the simplicial complex. For 3D data, for example, the first three Betti numbers count the number of connected components of tunnels and voids, respectively. More important, Betti numbers of dimension P can be easily computed working with the boundary matrices associated to the simplices in dimension P and P plus 1, and computing their ranks, as shown in the slide. Now, we know about algebraic topology and about simplicial homology, but in which manner can we leverage this algebraic tool in order to discover patterns and shapes in objects, images, and in general from dataset, maybe larger dataset or heterogeneous? For example, let's take a 2D shape sampled with points. Hence, we have 2D points on a 2D plane. How it can be understood through homology groups? The core idea of persistent homology, it is the most renowned tools from computational topology, is to associate to that shape, the sampled shape, a simplicial complex, and together with the way of building the simplicial complex. That means give a rule, a sequence of nested subcomplexes starting from the single points. Hence, I can show how the Euclidean matrix can be used to associate to the set of points in the 2D plane a simplicial complex by joining two vertices when the distance between them is less than a threshold. This threshold is the filtration parameters that tell us when it's the time to insert an edge between the two vertices. With respect to classical homology analysis, persistent homology explores the topological attributes of an object in an evolutionary context, because it analyzes the incremental growth of a space, as shown in the video before, by placing the topological events while the space grows. For example, the birth of a connected component and its death when it merges into another component. The longevity of lifespan of the topological events is interpreted as relevance. pH is nowadays the flagship tool of topological data analysis. In the analysis of real-world data, it is typically not a priori clear at what scale interest in topological features occur. By using a filtration connected to the scale parameter, persistent homology is able to capture topological changes across the whole range of scales and store this information in so-called persistent diagrams. This concept was first introduced by Frosin in 1990, who defined the size functions, which are the equivalent of the zero-dimensional persistent homology. But many other researchers simultaneously define the same or similar objects, and nowadays persistent homology is a successful tool for data analysis, and this success is mainly due to a few reasons. The persistent homology has found to provide powerful topological invariants, which have been successfully applied to data analysis. I may cite, for example, that companies for financial consultant services are found provide services based on core built on top of topological computations. And also there exist good algorithms, mainly based on linear algebra, able to compute persistent homology, increasing more scope and speed, most of them well implemented and maintained. Okay, but when you grow these simplicial complex through the filtration and compute at each step the homology groups, how can you represent, visualize this evolution? Through barcodes and persistent diagrams. In the first row, you see a growing complex, the RIPS complex, associated to the set of points sampled on a torus, the same set of the slide before. It is built using the Euclidean metric. In the bottom row, you see its barcodes in dimension 0, the red bars, in dimension 1, the green bars, and in dimension 2, the purple bar. This is nothing else a visualization of a parameterized version of the Betti numbers. Look at the longest feature in H0. It represents that along the sequence, only one connected component survives. A barcode is simply a collection of horizontal bars in a plane. The horizontal axis corresponds to the parameter growing the complex, our filtration parameter, while the vertical axis represents an arbitrary ordering of homology generators. The length of each bar is interpreted as the lifespan of the corresponding generator, the relevance. We have in parallel. Short bars represent noise, long bars represent important features. Persistent diagram is an alternate representation of a barcode. Instead of drawing A, B as a bar from A to B, we just draw a dot at coordinates AB. And in the figure, you see how to pass from one representation to another in a simple way. A persistent diagram is a set of points. There exist many distances that mathematically can be defined for point sets. Barcodes and diagrams may be compared efficiently using proper distances, such as the p-Wasserstein distance or the bottleneck distance, which is the limit of a p or the p-Wasserstein distance with p going to infinity. What's important is that persistent barcodes are stable with respect to perturbations of the data, and it was proved first in 2007 by Cohen-Steiner, Brunner, and Dara, and that barcodes are computable via linear algebra on the boundary matrix, as we already seen before. Nowadays, there are several tools for computing persistent homology, publicly available and quite performing. In the paper cited at the bottom of this slide, the authors provide benchmarks of the state-of-the-art implementations for the computation of persistent homology and the pipeline for the computation with an eye towards the desired application. Also, they use a range of synthetic and real-world datasets to evaluate currently available open-source implementations. Hence, this paper could help to understand which algorithms and implementation are best suited to different types of dataset and applications. But there is a drawback. Because pH-based descriptors are not only persistent diagrams and barcodes. Many other descriptors were defined because barcodes and descriptors are not so easily manageable. Multisets, points in the plane are not so easy to exploit in order to, for example, classify events or for other purposes. Because the space of persistent diagrams lacks a structure. This is the point. Different persistent diagrams may have different number of points, and several basic operations are not well defined. For example, addition and scalar multiplication. And this dramatically impedes their use in machine learning applications. In order to tackle these issues, a lot of attention has been devoted to vectorizations of persistent diagrams through the construction of either finite-dimensional embeddings. We may cite silhouettes, persistent landscapes, persistent images, and expected persistent diagrams, and also kernels, which means generalized scalar products that implicitly turn persistent diagrams into elements of infinite dimensional Hilbert spaces. Okay, hence we now have introduced a theory, persistent homology and algebraic topology, to study and analyze data, robust invariants, barcodes and persistent diagrams, and their derived descriptors, tools for the practical computation, at least, and we now are ready to apply them to data for pattern recognition and analysis purposes. The soundness, efficiency, and robustness of this class of approaches made it increasingly popular in the last few years in a variety of 2D and 3D imaging analysis and shape analysis applications. And first results addressed the tasks such as mesh simplification, segmentation, or image retrieval. Also, persistent homology is a tool that doesn't regard dimension. It can be applied in any dimension. Hence, in higher dimensions, these techniques have recently been adapted to form the basis of new clustering algorithms and data analysis tools. Okay. Here there is a list of some of the research domains in which pH methods have been used. I will focus only on some of them in order to show you some of our results and also results from other researchers. And I start from statistical shape analysis. In this case, we applied persistent homology to 3D data extracted from human faces in order to track the evolutions of patterns in face shape variation due to weight gain. We extracted facial landmarks, hence we associated a complex, simplicial complex, the Delaunay triangulation. And after that, we computed persistent diagrams for each sample and compared them through the bottleneck distances. After that, we applied the multidimensional scaling in order to project these points on a two-dimensional plane in order to track the evolution of weight gain through the landmarks, the facial landmarks extracted from the synthetic faces. Also, it is nice to mention these results by one of the main contributors to the computational topology, with Carson and Zamorodian and colleagues. This paper contains very important results. The space of high contrast patches of dimension 3 by 3 from digital images as the topology of a Klein battle. And this is a nice result that was followed by another paper by Perea and Carson in 2015, stating that texture could be represented through a Klein battle-based dictionary. Both of these papers open the route to a new compression of high contrast natural images through the Kleinlets. So it's quite a nice outcome of persistent homology techniques. Now let's talk about signal processing. A typical starting point in a TDA pipeline is to generate a simplicial complex from a point cloud. But when we have a one-dimensional signal, how to get this cloud? Discrete time series are typically visualized as scatter plots in 2 dimensions. This representation makes the local behavior of the time series easy to track by scanning the plot from left to right, but is often ineffective at conveying important effects which may be occurring over a larger time scale. One way of encoding a time-evolving process is based on the idea that some key properties of the dynamics can be unveiled effectively in higher dimension. And the procedure used to pass from the time series to the point cloud is the Takens embedding. After that, complex is built. We compute the persistent diagrams of the complex, then extract the F features, and then we can use these TDA features to classify events, to denoise, to, for example, also to detect, for example, periodicity in a time series. Okay. This is how Takens embedding translate time series in point clouds. maybe this is quite technical, maybe I can pass over. This is a visualization of how when the signal comes to 2D point set. And this is a list of the TDR features created to analyze signals. We can compute the total number of holes, relevant holes features, total number of holes, the information about the holes is contained exactly in the persistent diagrams. Relevant hole features means that we count only the number of holes over a given threshold size that are relevant with a great lifespan. Also, there are other features: amplitude of the diagram feature, mean support feature, argmax, average lifetime feature. All of them are used to detect events or classify signals. Also, persistent homology has been used to analyze data from multiple sensors. In this paper, we monitored the occupancy of specific areas or rooms in a smart building, extracting from a set of time series acquired by 3 different local sensors: electric power meters, accelerometers, and noise meters, and computing topological features to detect people in a room. We get nice results. Obviously, we needed to perform proper preprocessing, because the 3 time series were came from different sensors. Also, persistent homology has applications in financial time series analysis. The dynamics of financial systems are comparable to those of physical systems. Observations show that financial crashes are preceded by a period of increased oscillation in asset prices. This phenomenon translates into an abnormal change in the geometry structure of the time series. TDA has been used by GDI Katz in this paper to capture these geometric changes in the time series in order to produce a reliable detector for stock market crashes. And they show that topological descriptors used in the papers are much more robust against noise. And in the paper, they shows that the topological feature most performing this task is the persistent landscape. Hence, a pH-based descriptors, not a diagram or barcodes. Okay. Now, I should come to the end of my presentation, showing you that there is a fruitful interplay between persistent homology and machine learning. And this interplay realizes into 2 main research directions. The first aims at building a topological layer that could allow neural network to learn topological information. The other aims at studying the neural network training process, trying to look through the persistent homology tools into the training process. We already listed the pH-based descriptors. All these descriptors enter the persistent homology machine learning modeling flowchart. For different data types, that can be functions, point clouds, digital images, metrics, or network, different simplicial complexes are considered, with a suitable filtration parameter. Persistent homology analysis can be implemented by designed software. We know that we can choose which is the best performing for our scope. The result of the computation is transformed into feature vectors, distant measurements, or special kernels, which are further combined with supervised or unsupervised methods from machine learning. Hofer, Witt, and Niethammer were the first researchers developing in 2017 a technique to input persistent diagrams into neural networks by introducing their own topological layer, able to learn a task-optimal representation during training. While many strategies have been proposed to map this topological signature into machine learning compatible representations, they suffer from being agnostic to the target learning task. In contrast, Hofer and colleagues propose this technique, enabling to input topological signals to deep neural networks and learn a task-optimal representation during training. This is the list of the pipeline of their approach. Okay. Even though vectorization and kernel methods improved the use of persistent diagrams in machine learning tremendously, several issues remain. For instance, most of them only have a few trainable parameters. Therefore, it may be very difficult to determine which vectorization is going to work best for a given task. On the contrary, kernel methods are generally efficient but require large memory resources to compute and store the kernel evaluations for each pair of persistent diagrams. Hence, such methods are very costly with respect to memory usage and running time of large datasets. In the last years, many researcher groups defined and implemented topological layers to exploit topological features in deep learning pipeline. And these listed here are the most important results in this sense. In general, a framework using topological signals in a neural network could suffer from some limitations. It may rely on a particular filtration, it may lack stability results, and the differentiability of persistent homology generally is not guaranteed with respect to the layer's input. Among these results, we found very interesting the middle one, Persley. Why? Because Persley is one of the first neural network layers designed to handle persistent diagrams, and it is based on a very general framework. In fact, it is able to learn vectorizations of persistent diagrams, which encompasses most of the vectorization techniques used in the literature. Persley could use persistent images, persistent landscapes, persistent silhouettes as a particular instances, depending on the way the diagram points are turned into vectors and on the permutation invariant operations that is being used, the op you see in the figures. Also for this, you can find code and experimentations and tutorials on GitHub, and it is quite interesting to apply these tools to, for example, to a dataset of proteins for classifications, for example. But because of the stochastic nature of the optimization algorithms used in convolutional neural networks, the problem of understanding how they function is a problem in data analysis. Hence, a new trend is, as I already told, understanding deep learning with pH-based approaches. What we mean by this is that it is a computational situation where there are outliers. Okay, I must finish. In this perspective, we have foreseen that the interplay of persistent homology with machine learning and deep learning will continue to be successful, for example, in machine learning explainability, using the topological lens to look into the black box. And the cited papers refer exactly to this attempt. For example, Naizat, Ziknikov, and Lim last year published a nice paper about the questions in the title. And the findings were that neural networks operate by changing topology, transforming a topologically complicated dataset into topological simple one as it passes through the layers. The second fact found is that the reduction in Betty numbers is significantly faster for ReLU activation compared to hyperbolic tangent activation. The third fact is that a shallow network changes mainly geometry, while a deep network spreads the topology changes more evenly across all layers. So, thank you for your attention. I hope to have provided you the overall picture of the impact of persistent homology and computational topology in topological data analysis and machine learning work.
Okay, thank you for brilliant presentation, Professor Pascali. Colleagues, have you any questions? Maybe I have one remark. Okay. Dr. Pascali is a visiting professor, and we cross with her in international conference on pattern recognition. This year it was in Italy, but it was virtual online. And topological data analysis is very actual, I think, for our department. Semantics, because machine learning is about shapes of data, definitely. And we plan to join investigation and use machine learning techniques and TDAs for processing images or signals, speech signals. And we plan to submit joint paper to Symmetry MDPI quartile Q2 journal. And I invite you and your visiting professors to make joint papers in this journal, because I'm guest editor of this issue. And if you have questions, I think you can use chat. Thank you again, Dr. Pascali. We go to the next speaker. It will be Dr. Muzaffarov. Are you ready? Okay. So the next speaker may be Professor Kirsky.
I am not sure. I am ready now to start my lecture or presentation. But
the next speaker will be Adam Michalski.
Okay.
He's professor at the Institute of Mechanical Engineering, Warsaw University of Life Sciences from Poland, and the topic of his report will be image analysis techniques for assessing crop health. Please.
Okay. Thank you very much. Yeah, okay. Yeah, we've got a little bit interference. in the voice, I heard someone about you. So, okay, let's start. Wait a minute. This one, and switch on my presentation. Do you see on your monitors my presentation or not? Could you tell me? Hello? Can you see my presentation or not? I cannot hear you.
Yes, it's okay.
Yes. Oh, thank you very much.
Thank you.
So let's start. My name is Adam Ekielski. I am associated professor on the Faculty of Production Engineering at Warsaw University of Life Science. And on Friday, as I remember, I've got a lecture, 2 hours lecture about image analysis. So today I would like tell you a short version of my lecture and tell something about my experience in this topic. Now on my university, you know, Warsaw University of Life Science, there is the biggest agricultural university in Poland. So the main of my topic now is preparing biosensors from lignin cellulose, but parallel we all time work about image analysis and implementation of image analysis methods or technology to agriculture. So I've got on the chart some question about Apple recognize. Yeah, we've got. I would like to answer on this question. Firstly, we've got a method and technology to recognize apples and plums, but we cannot join our technology to robots, agro robots. Now. We applied our systems to fruit sorters. So of course, we can combine and try to apply it to cooperate with robots. But back to my presentation. So I would like to present, as I told, by experience, and I think that it was a long way with image analysis for agriculture techniques. And on this slide, you can see, for example, my colleagues which tried to find a height of the wheat. It was a break point for my team, for me and for my team, when we try to look on this image analysis methods from different sides, which I try to explain how we can try to solve that problem. Why? For example, on this picture on the left side, you can see this. My colleague used, I switch on a pen. We tried to find a number automatically, to find a number of plants per 1 meter. Okay, we done it. Also, next work, it was, you can see there is a maize field, there is a maize plants. And as you see, there are different between this area and this one. And first question was from our consumers and from also from industry, agriculture industry was, first question was that this damage of this plant is enough to rebuild, or this plant has got a potential grow up and the yield will be enough to feed back costs of production. So firstly, on my presentation, I would like ask and answer on 3 questions. First, why we need to evaluate quality of crops. First and mainly, a long of time, the one answer and the main answer it was that we would like to increase the yield while minimizing of production costs. But since 5, maybe 6 years, the second answer is also important. I think sometimes that it's more important than the first answer. Reduction and minimizing herbicide amount applied. And next question, when we answered for that question, we can tell what does it mean that crop or plant is well or has got a bad situation. First, in all of papers, I think so, when we can read that's the first index, there is a plant size. Sometimes it's used a canopy cover. Does it mean how many leaves are under the ground, under the soil? Above, sorry, not under, but above soil. And next quality crops index, there is photosynthesis intensity of plant. What does it mean? Sometimes we can go big leaves, but photosynthesis is very low on a very low level because, for example, haven't got enough water in the soil. Next answer, it's an amount of fruits or seeds on the plant or on the field, because it's we need to divide. Sometimes I will be use only one plant or some plants. Sometimes I try to tell about a larger area. It's a field. Our next question is the plant is in a mature stage. It doesn't mean is we can pick up these fruits. And last one is a number of weeds on the field. Because sometimes maybe you know, I think that's everyone knows that if we has got a little amount of wheat on the field, it isn't not there are no problem with the growing of our main plant on this field. And when the number of wheat cross the border amount, it doesn't mean that some weeds will be more than not then, but will be more and will be influence on growing on the main crop. We need to activate our systems to damage of weeds. And how many weeds per square meters it should be? It depends from the plant, main plant. So next question is, which we should answer, what can be a reason to poor plant's condition state? Why the plant is with wrong condition? And generally, as I wrote on this presentation, generally we can tell it's stress. Stress is agrobiotic stress. It doesn't mean it's too less or too much water, too less or too much sunshine, salinity. But another reason, there is a crop damages by animals or weather anomalies. And we should estimate of this indexes or this conditions or these reasons. Another on the right side of this picture, I would like to show you, of course, it isn't maybe clear. Someone today talk about it. It's recognized of weeds and main plants. We can do it. How we try to do it? I tell later. Of course, technology is technology, and we need some auxiliary techniques and some instruments. First, carriers, because we use to our research, we use cameras or video sensors. As for example, this one, of course, it isn't, where's this pen? This camera isn't Polish production, it's from Germany, it's a class solution, but we've got a similar solutions. And we can fix on these cameras on the vehicles, on the ground vehicles, on the drones. But a lot of sensors is used as a personal handling machine or indicators. And what does it mean? It does mean we've got three possibilities to use this machine, these indicators. Next question: how we can analyze? Not how we can analyze, but what kind of weight we need to use. Of course, first, visible waves. It's easy. RGB systems, LAB. If you need, we can use it. Next one, there is near infrared waves. That spectrum is very good when we would like to estimate water contained in leaves. Next area, next range, there is a terahertz frequency, ultra short waves. With that frequency, there is a problem because, for example, in Poland, we've got a problem to access to these instruments because, you know, these instruments, there is, as I know, as a person told to me, for example, in Warsaw, we've got only 2 instruments, and 2 of them there is in military university. Why? Because there is a system, I think so, that it's similar to use as radars. But as I tried some years ago to use the terahertz frequency sensors, the feedback was very nice from feedback when I measured state of plants. The feedback was very nice, and I think that's the future will be with that instrument also. Next question is, how many waves we need to analyze? Of course, hyperspectral or multispectral, it's very known. Difference between multi and hyperspectral, there is a number of waves which we analyze. Sometimes when I ask someone in industry, engineers cannot clearly answer me what is the difference between a hyperspectral and multispectral, and but I think that's it's a little bit easy when we analyze less than 10 waves. It doesn't mean there is multispectral, more than 10 waves length or frequency. It doesn't mean hyperspectral. There is easy to understand and without any theoretical divagation. And next question, there is image post-processing techniques. I use difference. Starts from simple border methods as OTSU. We discussed on the chat about OTSU method. Next, use fractal methods. Does it mean chaos systems analyzing? And lastly, I use deep learning or artificial intelligence systems. There is, and that is, you know, the idea how measure of state of plant state. It's a core, but we need a shell about it. A shell, there is a carrier, spectrum range, spectrum wave number, image post-processing techniques. Now on this paper, you can see a traditional system to measure of some vegetation indexes. It's nice when we would like to use on 1, 3, or 10 points on the field, but if you would like mapping of the field, it's too much work with it. So we use in our investigation from multi-rotors aerial vehicles when we mounted a hyperspectral camera or camera on RGB cameras. Sometimes it's combined. It doesn't mean we use 3 cameras there to make a photo. If anyone asks us, okay, why did you use multi-rotors? You cannot use a fixed wings UAV. It doesn't mean as similar as normal plane. Yes, we use it, but the speed of flight of fixed wings UAV is it doesn't mean simply it's too fast for system analyzing. That's better. Of course, we can we can examine or we can check less field, but it will be more accuracy. Okay, how we can use this image analysis with multispectral and hyperspectral imaging? Hyperspectral imaging analyzes systems a lot of time. It was too expensive for universities, but now it's cheaper and we can get one. So we used a multispectral imaging analysis. And very often, we need to remember that multispectral imaging analysis, it's even we can use only 3 wavelengths. RGB, for example. It doesn't mean standard camera will be a camera for a multispectral imaging analysis, but we, of course, we lose some information when we use only RGB systems. Hyperspectral, you can see on the right side of this picture, there's a spectrum which is get from waves, which distance between waves is about 10 nanometers. Oh, it's of course there is a huge of number occurs, but we have got really very nice data. And how we can analyze the data which we received from this multispectral or hyperspectral sensors. First, we need, very often, I think that's the most popular system, there is a system with passive. What does it mean? We measure reflectance. It doesn't mean make a photo and looks what is inside on this photo and try to analyze information of the photo. But this is passive method. This passive method is very nice, cheap, fast, but it's depend from the weather condition, environment condition. You know, because reflectance is reflectance from sunshine. If sunshine is, for example, in Poland now, now I see through the window it's very dark. It's gloomy. Gloomy doesn't mean raining. The reflectance will be different than during sunshine day. But as I told, it's easy. Next one, there is fluorescent measure methods. It's active methods. Active method, what does it mean? We try to find a chlorophyll activity as index of quality or quality of plant. It doesn't. How we can do it? It will be on the next slide. So I stop now. At text one, there is image texture estimation. It's the oldest one of the methods. We can use to edge discrimination, for example, or we try to find the shapes, area, or find the RGB parameters. Reflectance methods. You know, there is so many reflectance methods and indexes. So I think that's it's a reason why this method is not so much good. Because if it will be only one or two reflectance indexes or vegetation indexes, it will be enough and it will be nice. It doesn't mean that method is correct. But when you see on the next slide, no, okay, it's one is also good. The most popular index, there is NTVE index. NTVE index, there is an index, you can see there is a spectrum of near infrared spectrum minus waves in red color divided by near plus red reflectance of red color. And that is the most popular, as I thought. You can see on this picture, of course, I am so sorry for the Polish words, but you know, you can see on this NTVE index in June, same tree, and in September. Okay, you can do and estimate, but you know, estimate a tree condition or leaves condition. No, it's rather leaves condition, but leaves it's also combined with a plant condition. But NTVE with NTVE indexes.
3 minutes remain.
Wow, okay. I should be more quicker. Thank you very much for your comment. So we can use another in industry. We can use another one. For example, one of them, there is TGE index. You can see comparing of this same field with and different indexes. Simply, you can see that you can find the differences. But not only these two indexes is used. You can see I on this table, on left side table, I added 1, 2, 3, 4, 5, 6, 7, 8, 9 indexes which use near infrared waves or red or green or blue waves. And if I would like to tell more, I can and more precisely, I should add 3 or 4 more indexes. What does it mean? It doesn't mean that anyone is so much good that will be separate and reject another ones. So I would like to use another, in my investigation, I would like to use another methods. It's active methods to estimation of chlorophyll activity. I used a Kautsky effect. Kautsky effect is based on rapid increase in fluorescence after lighting. It doesn't mean when we try to make a shot, light shot, very fast, it's only a half of a second. And now we observe what happened with chlorophyll. Chlorophyll starts to fluorescence, imitate of light. And because I haven't got so much time, so I will be a little bit quicker. So you can see, for example, on this picture, a response to leaves. One of them there is a on good condition leaves. Another one there is a leaf with a poor condition. You can see second one has got a different curve. And we used this method to estimate a condition of wheat plants. For example, of course, if I missed this slide because it isn't so much important for me. The most important is this slide. Yeah, this one. There's last our research, and you have got a response of wheat. You've got there's a sample. So there is a sample up to 10, and what we can see there is the main problem. There is a noise. Noise. It doesn't mean signal is noisy. We need to reduction. So we clean the signal, and you see there what we received, and when we used artificial networks, we can extract some important data from these noisy signals. You can see on this picture, it will be, I think so, the last one on my presentation, but it's the most important. For example, we made a experiment when we use a 3 level of herbicides added on the field. It does mean 3 liters per hectare, 1.5 and half. And measured reaction of these plants. That was so different. So I would like to tell what we can do. First, it's a fresh research. So it's we need to work much more about it. But after 10 minutes after herbicide application, we can tell if this plant will be dead or not. It's a revolution, in my opinion. Next, my PG students worked some experiments later, and they received above 80% correctly level for correct prediction of the next stage of the plant. Why it is so much important? Because we can reduce use of herbicides. For example, a sprayer is going on the field, and separately dose the herbicide only on this place, which before half an hour earlier, the dose was not enough for the wheat, for example. Because you should also remember, or you know that wheat grows up not uniformly. It doesn't mean some of plants, wheat plant will be grower. It's more, you need more of herbicides on it, some of less. It doesn't mean we can reduce amount of herbicides. I think so. That's not less, but reduce about 20%. I think so. We haven't got enough so much many experiments, but we estimate that it will be 20% less herbicide per on the protect of the plants on the field. And last one, absolutely last one slide. Last method, texture of an image information, and we can use contrast, image coarseness, regularity, anisotropy. Some years ago, I used a chaos theory to image analysis, and you can see there Oh, there is an Apple. As, one colleague was asked about this Apple. Of course, it isn't Apple, it's rather orange, but the PG student, she wanted to show Apple. But we used, for example, here's the coefficient to estimate of plant condition. For example, it's simple example when we, for example, shown if is any differences when the field is flat or after the tractor wheels damaged some plants there. It's very nice to see anisotropy of that system. And I think that's on that slide. I finish my presentation. I don't want to be longer than another prelegents, but remember that's not all. For example, weeds we need to reduce. What does it mean? Some of weeds, some of plants, which are weeds, cannot grow up so much more. For example, some of the weeds plant life is finished after some time. It doesn't mean we cannot reject all weeds because it is not an economy. It's no sense economy. And I think that this idea, this idea of smart farming or I don't know, intelligent farming, the name is a difference. Okay, thank you very much for listening my speech, and I'm waiting for any question. Thank you very much.
Thank you very much, Professor Kwielski. And I have a few questions, but unfortunately we have no time for my question. But I invite you to continue our communication. And I think I can see enough common points, and we are involved in a couple of research which have many common points with your research activity. And I think we should begin our collaboration and looking for further funding.
Yeah.
Thank you very much.
So. Thank you very much. Thank you for your promising. I think that it will be very nice to cooperate and find the funds, for example, for next research. So thank you again. Thank you very much.
Thank you very much.
Thank you very much, Adam. I see it was a hot discussion in chat about your presentation.
Yeah. So excuse me once again.
Was saluted.
Yeah, my email is in invitation. If you would like to contact with me, send a message to me by mail, for example. It will be easier. Thank you.
It's interesting. Image processing researcher too. Colleagues, we should go to next speaker. It will be Muzaffarov, Ишольд Зигбенджаевич. Вы здесь?
Да, здесь. Меня слышно?
Да, я сейчас вас слышу. Так, вы можете открыть презентацию. Вот там есть стрелочка. Открыть панель рядом с микрофоном. Открыть панель обмена контентом. Что такое должно быть, чтобы поделиться экраном. Ага.
Так. Видно рабочий стол?
Вижу презентацию. Да. Система работы похожа на работу. Тогда я вас представлю. Our next speaker is Dean of the Faculty of Mathematics, Associate Professor of the Department of Programming, Jan State University, named after Gafurov. He is from Tajikistan, and the topic of presentation is solving complex systems of Boolean algebraic equations. Пожалуйста, начинайте. Старайтесь 15 минут уложиться.
Спасибо большое. Ну, я буду говорить на русском. Вот. А слова, которые я буду говорить, ну, я в виде слайдов, в виде презентации там сделал. Вот. Будем говорить о проделанных совместных работах, в том числе и с финансовым университетом при правительстве Российской Федерации, наш университет и университет управления Рязани. Вот. Будем говорить о применении гармонической функции к решению булевых алгебраических уравнений. Вот.